Family of courses in the cement industry. Present to you. This course will explain the main drive system of a rotary kiln. Is the mechanical powerhouse responsible for rotating the rotary kiln shell at a controlled variable speed? Given that a rotary kiln can weigh several thousand tons, including the refractory and material bed, the drive system must provide immense torque while maintaining high precision. A. Components of the main drive system. A standard modern drive system typically consists of the following components in sequence. 1. The main motor. Type. Usually high-capacity AC motors, variable frequency drive, VFD, or in older plants, DC motors. Function. Provides the primary rotational energy. Variable speed. It is crucial that the motor speed can be adjusted, example, 0.5 to 5.0 revolutions per minute, to match the feed rate and chemical conditions inside the rotary kiln. 2. The main gearbox, reducer. Function. Since the motor spins at high speeds, example, 1000 euro 1500 revolutions per minute, and the rotary kiln rotates very slowly, the gearbox reduces the speed while drastically increasing the torque. Lubrication. These gearboxes have dedicated oil cooling and filtration systems to handle the heat generated by the massive friction. 3. The girth gear, bull gear. Description. A massive, multi-segmented gear ring bolted to the rotary kiln shell. Mounting. It is attached via spring plates, tangential plates, to allow the rotary kiln shell to expand thermally, without distorting the gear. The rotary kiln shell reaches temperatures up to 408 degrees C, causing it to expand. If the girth gear were welded directly to the shell, it would crack or warp. Instead, it is mounted on tangential spring plates that act like a flexible bridge, absorbing the expansion while keeping the gear centered. 4. The pinion. Description. A smaller gear that meshes directly with the girth gear. Function. It transfers the torque from the gearbox output shaft to the girth gear. Some large rotary kilns use a dual drive system, with 2 pinions to distribute the load evenly. 5. Auxiliary drive, emergency or inching drive. Components. A smaller motor, often diesel or a separate electric motor, and a dedicated small gearbox. Function. Used during power outages or maintenance. It turns the rotary kiln very slowly to prevent bending, or sagging, of the shell while it is hot. B. Maintenance and monitoring parameters. To prevent catastrophic failure, the following are monitored 24 hours a day, 7 days a week. Parameter why it matters. Gear vibration. High vibration indicates misalignment or worn teeth. Lubrication temperature. Overheating suggests gear friction or gearbox internal failure. Pinion/gear mesh. Checked using lead wire tests to ensure even contact across the tooth width. Motor amperage. A sudden spike in ampere indicates a mechanical obstruction or coating fall inside the rotary kiln. C. Operational protection, interlocks. The main drive will automatically trip, shut down, if 1. The lubrication oil pressure drops. 2. The gearbox or motor temperature exceeds safety limits. 3. The rotary kiln thrust, longitudinal movement, is too high. 4. The auxiliary drive is still engaged. Summary. Without a reliable main drive, the rotary kiln is useless. The most critical aspect for an operator or maintenance engineer is ensuring perfect alignment between the pinion and the girth gear, and maintaining a consistent spray lubrication system to prevent metal-on-metal wear. Thanks for following the channel, Courses in the Cement Industry. And please help us to continue and provide more information, by subscribe to the membership, and inviting your colleagues to watch this channel.